Welcome back, class. Today we're doing classwork 10.4, writing exponential growth and decay equations. So in previous units, you looked at multiple representations of linear functions. In this lesson, you'll use multiple representations to learn more about the growth ratio and the starting point of exponential functions. So a bungee jumper leaps from a bridge. The diagram shows that jumper's height above the ground at the top of each bounce. Use the diagram to make a table and a graph. So let's start with our table here. So we can see at first bounce, we are at 200 feet. So at bounce number 1, we're going to be at 200 is my height above the ground. At the second bounce, we're at 80. And then my third bounce, we're at 32. We're also going to plot that information into the graph. So on my graph on the bottom here, this is going to be the bounce number. My x is going to be bounce number, and my y is going to be the height. So I'm going to fill in this information. I'm going to go by ones on my bounce number. And then on my height, I'm going to go by 25. So this is going to be 25, 50, 75, 100. And then after I get to 100, I'll start labeling every 100 just to save room. So this will be 125, 150, 175, 200. Go ahead and finish completing the table on your own. I'm going to pause the video, and we'll resume when we're complete. All right, my graph is completed out. I've got 200, 300, 400, and 500 here. I also plotted my points. So after bounce 1, it's at 200. After bounce 2, it's at 80. And after bounce 3, it's at 32. So make sure your graph is complete, your table is complete, and we'll go on to start answering the questions. Question A, examine the table. What is the growth ratio for this problem? Well, we're not given the growth ratio in this, so we've got to figure it out by using math. The way I'm going to do this is, remember, if we go from 200 to 80, there must be some number that we multiply that takes us from 200 to 80. And the same thing is true going from 80 to 32. So we want to know times what number gets us there. In order to figure this out, we've got to work problem backwards. What is the opposite of multiplication? If you thought about division, you're correct. So in order to get what number I multiply by 200 to get 80, I've got to divide 80 divided by 200 instead. So in your calculators right now, type 80 divided by 200. So 80 divided by 200 and see what you get. If you got 0.4, you are correct. And if you want to check and double check to make sure you're right, take one of these numbers, like 200, and do 200 times 0.4, and you should get 80. So for question A, what is the growth ratio for the problem? My growth ratio is 0.4, or 0.4 if you want to say it's that. Question B, how can we use the growth ratio to determine the height of the bridge? So we are going to use this growth ratio to get us going in this direction. And hopefully you know that if we got 200 times 0.4 to give us 80, then 80 divided by 0.4 gives us 200. And we did just double check that to make sure that's the case. So in order to find this one, we've got to do the same thing. We know it's going to be this number times 0.4. So in order to work backwards, we're going to take 200 and divide by 0.4 to give us that. So type in your calculator 200 divided by 0.4 and see what that is. And that number you should get is 500. So I'm going to write how we can use the growth ratio to determine the height of the bridge. So why don't you pause your video right now, see if you can come up with something, and then when you come back, I will have what I wrote. All right, so on my paper, I wrote working backwards, we can take 200 and divide by the growth ratio. So I took 200, I divided by that 0.4, I worked backwards, and that got us an answer of 500. So let's make sure we also plot that point on our graph. So 0, 500 right up here. After you're done with this, let's continue to the next video and answer the rest of question 1.